Recently, I have replaced the capacitors in this Krell FPB-400cx and done some modifications. In this video, I'm going to include some of the pictures and videos to show you the processes. The Krell FPB series amplifier is relatively easy to work with because it's kind of a modular design. So by removing the top panel and the bottom base and then the back plate, you can very much separate the left channel and the right channel blocks. As you see in this picture, this is the right channel blocks, and with the heatsink in the back, and you can see the decoupling capacitor on the right hand side and some other regulation circuitry and the voltage gain sections, and all on this car. And by removing the screws on top of these board, the surrounding ones, right? So you can very much separate this board from the power board, which is shown here, right? You remove that board on top, you expose this board. It's a very easy process. And then you can have access to the component here. For instance, if you want to recap the capacitor here, you can do it. But in the video, I'll show you some better ideas instead of replacing these tons of capacitors here. All these actual capacitors are 47 microfarad, and since they are located in this region, very close to the transistors, power transistors, and the heatsink, it's quite hot, and there's another board covered above it, and the heat is very hard to dissipate from outside this region. So that's the reason these capacitors tend to fail prematurely. So replacing them is a very good idea, because after almost now 20 years of usage, these start to dry out. However, it's a huge amount of capacitor to replace, and it's not easy, right? You can see the location and so on. One thing I'm going to do is I will use a bigger capacitor to put it in parallel of these capacitors. I will show you in the schematics the reasoning behind it. This is the schematic of the power stage. I circled those actual capacitors in red, and you can see each of them are 47 microfarad. These actual capacitors, normally they have very high series resistance, inductance, so they're not ideal really for power decoupling. And radio capacitor I'm going to use is much better in terms of series resistance and inductance. And also, we just put directly parallel with these old ones, because normally these old capacitors, the failure mode is just increase of the series resistance and decrease of capacitance. They never short, right? So we can just put a new one in parallel of this, and that will significantly improve the coupling of the mid-range and the high-frequency range. So I will show you the location I'm going to put the added capacitor, which is 100 volts, 470 microfarad. For the new added 470 microfarad capacitor, we put them at the end, because that way, once we put the board on top, we can bend it flat, and I see the room here. We have the room to allow this capacitor stand up. above that board. So similarly on this side, we do the same thing. So finally assemble everything together. You can see these are the added 470 microfarad capacitors at this end to flush with the cover and the bottom plate. Should be no problem. This is the best place I found for the added capacitor. And then I upgrade these capacitors to 17,000 microfarad each. The original is 6,800, so we are about 3 times more capacitors. So even though it's regulated voltage, but I still think a good reservoir here should help the transient response.